All right, so here we got sand is deposited into a pile with a circular base. The volume of the pile is given by V equals R cubed over 3, where R is the radius of the base in feet. The circumference of the base is increasing at a constant rate of 5 pi feet per hour. I don't know why I said that circumference in a weird way, but anyways, when the circumference of the base is 8 pi feet, what is the rate of change of the volume of the pile in cubic feet per hour? Okay, so this is a related rates problem, as you probably figured. So these ones are fun. My students love these, and I'm sure you guys do too. But they're actually kind of cool because you kind of see how calculus is applied. But they tend to be a little challenging because you have to really know how to do the calculus and have some intuition about just physics and just like how the real world works. But anyways, when you're doing a problem like this, make it clear what you want to figure out and put it in calculus, like equations. That's going to help you get the ball really rolling if you're struggling with problems like this. So we're trying to find the rate of change of the volume of the pile. We're trying to find dV dt at a specific, with a specific condition. So when the circumference, when C equals 8 pi feet. We want to find this. Now we're given that the circumference of the base is increasing at a constant rate of 5 pi feet per hour. So the derivative of circumference, so dc, we'll say dc dt, is equal to 5 pi. So we need to find now the equation for dv dt. We want to differentiate this, but we want to differentiate it so that we only have circumference or no radius in our equation. We could also convert it to radius, but it might be a little more tricky, but it actually just depends on you. Anyways, make sure you know your geometry. Circumference C is equal to 2 pi r, so 2 pi times the radius. So that means then circumference over 2 pi is equal to r. Now, then that means that we can rewrite our equation for volume as C over 2 pi all to the third power over 3. And simplifying this, C cubed over 8 pi cubed all over 3, and dividing it, we'll get C cubed over 8 times 3, so it's over 24 pi cubed. So this is our equation for volume in terms of just circumference. So now we can simply differentiate this. So we're going to find dV dt. Let's go up here. dV dt will be equal to, remember this is just a constant, so I'm going to put that in front. So 1 over 24 pi cubed. Don't mistake the pi with a variable. That's common for some students to kind of see that pi and want to do something with it. It's just a number. So we'll just leave it in front as a coefficient. So we're really differentiating just C cubed. So using the power rule with 3C squared, but also we need to use chain rule because we have a composite function, kind of like implicit differentiation. We're differentiating with respect to time. So we're going to multiply by dc dt. And now pretty much the calculus is done, actually. That was easier than I thought. We just got to plug in the values for C and dc dt, and it's just algebra now. So dv dt, so we got C, so 3C cubed. Remember, we have C as 8 pi, so we're going to have 8 pi cubed, or sorry, 8 pi squared. That'll be all over 24 pi cubed, and dc dt times 5 pi. So yeah, so it's just an algebra problem now. So the 3 and the 8, those all cancel. 3 times 8, 20, that cancels. Pi squared, pi cubed, this pi cancels. And Oh, whoops, sorry, this is not going to cancel exactly. This will be times, it'll be an 8 still. It'll still be an 8 times 5 on top. So let me actually rewrite this a little more. Let me just not cancel anything right now so it doesn't be confusing. So I'm going to square that. And we do that in breakfast as well. I hate squeezing. So dBdt, that'll be 8 times 8, so 64 times 3. So 3 times 64 pi, and you have pi there, so pi times pi times pi, so pi cubed times 5 on top, and we have a 24 pi cubed in the denominator. The pi cubes cancel. 3 over 24, that becomes an 8. 64, 8 times 8. So we have an 8 times 5 left on top, all over just, yeah, just 1. So all you have is just 40. Pardon my algebra, I know it's a little messy, but this is just algebra. You shouldn't have an issue with that, hopefully. So the answer is just 40. The answer is C. Rehydrate a little bit. Like 25. All right, these ones are like, these are special problems because these ones kind of can really send you down a rabbit hole of tedious calculations if you don't catch what they're doing, or what the math is. Remember, this is just the formal definition of derivative, of a derivative. If you remember from unit 2 where you had to find the derivative the fun way, you had to do like 10 lines of work doing some, factoring or, limit canceling and deltas and all that. This is just the derivative of e to the x, but it's evaluated as specific points. So this is the derivative of e to the negative x, you could say, when x is 1. So e to the negative derivative, e to the negative x, is just going to be negative e to the negative x. And so then this will just be, when you evaluate it for x equals 1, this will just be equal to negative e to negative 1. They're probably going to have it, yeah, they're going to have it like in that form. So negative 1 over e. The answer will be D. Yeah, so this is one of those that they're just trying to get you. Don't try to do some long calculation, because remember, you want to be able to try to find a way to do these in less than 2 minutes each to stay on pace. All right, 3 more. Let's try this over and see if I can do this in a reasonable amount of time. 26. Let f be the function given by f of x equals x cubed plus 5x for what value of x in the closed interval 1 to 3 does the instantaneous rate of change of f equal to average rate of change of f in that interval. Okay, so it may sound complicated, but it's actually not. All you're basically doing is finding the derivative and setting it equal to f of b minus f of a over b minus a. The average rate of change is just the slope. When you guys learn it back, in algebra, and you don't, if you have some, remember again, you have some complicated equation that's, hard to, calculate to figure out the function for, but you just take an approximation of how it's changing by taking, an average rate of change, the slope of a line through the endpoints. Anyways, so we have the interval 1, 3. So we have f of b, or f of 3, minus f of 1 over b minus a over 3 minus 1. And we want to set that equal to f prime of some value, let's say some value in the interval, let's say f prime of c, some value of x. So we essentially need to solve for that value of c. Let's first evaluate what this is. F of 3 will be 3, 9, 27. 27 plus 15. Minus f of 1. So 1 plus 5 minus 6. All over 2. So 32, 42. 30, 30, 32, 42, 42, 36 over 2. So 18. We want to make 18 equal to f prime of c. So let's find the derivative of the function first. So f of x is equal to, using the power rule, 3x squared plus 5. So we just set this equal to 3x squared plus 5 and solve. Remember, c is just a value of x. It's just a standard value of x. We're solving this. 18 minus 5, 13 divided by 3. 13 over 3 equals x squared. Taking the square roots. The square root of 13 over 3 will be x, or that c value in that interval. So our answer would be B again. Nice. 27. If e to the xy minus y squared equals e minus 4, and then if x equals 1/2 and y equals 2, dy dx equals. All right, well, this is going to involve implicit differentiation. So what we have going on here is, some intimidating, function. And if you're going to integrate this with, with respect to, or you're going to integrate this implicitly, remember, when you're integrating a function e to the x or e to the u, that part always stays. So we're going to have e to the xy times the derivative of xy times the derivative of xy. So this is just a product rule. Let me write it out. Let me just write it out here, xy. I want to find the derivative of xy. So the derivative of x is just 1 times y plus, we hold the x as is, plus x times the derivative of y. So then also just dy. But since we're doing implicit differentiation, we have to multiply it by dy dx. And then we take the derivative of y squared, 2y, and again, using implicit differentiation times dy dx is equal to the derivative of e minus 4. Remember that e is just a number, so this is just some number minus another number, so it's just 0. And now we just solve this as if it's algebra, which it is, sort of, for dy dx. So let's factor out the dy dx. Remember, this is being multiplied by both of those. So we're going to have dx. And let me put the y in front, so it's a little easier to see. Y times e xy plus, we have dy dx. I'm going to put that outside first. Times x times the e xy. Because that, remember, that's being, that takes care of that. But we also have the minus 2y being multiplied by dy dx equal to 0. So I took factors, I basically factored this dy dx and this dy dx out of this and rearranged it. So let's stare at that in case you're a little confused, but don't get too scared or intimidated by these. Just treat them as if they're algebra, like it's an x, y, z, w, like variables. Then we're just solving for dy dx. We're going to subtract this and then just divide by this. So dy dx will be, we subtract this, negative y e to the xy, divided by this, x e to the xy minus 2y. And here's our equation for the derivative. And then we just evaluate this for x equals 1/2 and y equals 2. So it's just some simple algebra. So So negative, so we have negative 2 times e to the 1/2 times 2 times e to the 1/2 times 2, so e to the 1, so just e. X is 1/2, so we have 1/2 times e to the 1 again. X is 1/2, y is 2, so e to the 1 minus 2, y is 2 minus 2 times 2. Okay, so let's look what we got here. It looks like they're going to have their answer like very strangely simplified. We have negative 2e on top. We have a 1/2 e minus 4 in the denominator. We don't have any of that in this form here, so we're going to do some, magic. What we're going to do is we're going to factor the 1/2 in the denominator. We're going to have 1/2 times e minus 8. And then, just dividing by that, you'll get negative 4e over e minus 8. And they're not going to have negatives, I bet. Yeah, they're going to have negatives. So what we're going to do is factor out negative 1 out of this whole thing. We're going to have negative 1 times 4e on top over a negative 1. We're going to rearrange this. 8 minus e, let's see probably how they're going to do this. It's negative 8 plus e, same thing, it's just rearranged. Those negative ones cancel, and so you just get 4e over 8 minus e. And so your answer is C. Yeah, I'll let you know, I also do get annoyed with the way they'll have their answers when you're dealing with these type of equations. And that's really has to do more with the next math classes you'll be taking, if you keep on taking it in different courses called differential equations. Have some formal way of of expressing their final answers and all that. But I definitely can relate to these problems when you're checking like your textbook, the answer doesn't match your answer and you think they're wrong, but it's not because it's just not in that same form. Anyways, just so you know, I understand. All right. Last one. Let f be the function defined by f of x equals x cubed plus x squared plus x, that g of x equals f inverse of x, where g of 3 equals 1. What is the value of g prime of 3? Okay, so it's going to be really helpful to just memorize the inverse derivative function. So if f and g are inverses of each other, then the derivative of g of x will be equal to 1 over f prime of g of x. You'll usually have some form of this in your textbook or in your notes or something, but it'll save you a lot of time when you're working with these types of problems because you don't have to derive it or be frustrated about how to do them. Anyways, we're trying to find g prime of 3. So g prime of 3 will be 1 over f prime of g of 3. Now remember, or make sure you understand, the inverse function gives you the output as the input, or the input as the output, depending on what what you're looking at. So g of 3 is 1. Well, I guess it's already given to us, so this will just be, so g prime of 3 will be equal to 1 over f prime of 1. Because g of 3 is 1. And so we just have to now find f prime of x and evaluate it when x is 1. And then we just an algebra. So f prime of x will just be 3x squared plus 2x. And then so f prime of 1 will just be 3 plus 2. So g prime of 3 will be, oh, whoops, plus 1. My bad, that's right. Plus 1. So f prime of 1 will be 3 plus 2 plus 1, or just be 6. And so this will just be 1 over 6. And that'll be your answer. The inch will be C. All right, we're done with the first section of this exam, that is. Take a break.